Today we're going to learn about relations and functions based on conjunction junction. Relations are a set of coordinates written as x, y. Here's an example of what a set of coordinates looks like. If you notice, we can take our x values and write them as one set, and those are considered our inputs, so our x values, also known as the domain. Our y values are our set of outputs, also known as the range. There are four different ways that you can write a relation. You can list them as a set of ordered pairs, which we just saw. It can be shown as a mapping situation. It can be shown as a table of values, and it can also be shown on a graph. A function is a specific type of relation that relates one set to another. A set of ordered pairs x, y, where each x coordinate is matched with one and only one y coordinate. You can see that functions are relations, and they can also be represented in the same way. Listed of ordered pairs, mapping, table of values, and graphing. It is very important that you understand that a function is a relation. So it's represented inside of the relations. Okay, here's one of the tricks in order to understand the difference between a function and a relation. If something is a function, the x values will not repeat. So if all of the x coordinates are different, then the relation is a function. If any of the x coordinates repeat, it is not a function. So let's look at some example. I'll bring this train right into the station. While we're doing so, we are going to look at the coordinates and determine which one of these are functions and which one of these are not. So looking at the green train, we are only going to focus on our x values. So I have a 2, 3, 4. Every single one of those x values is different, so we can say that this is a function. Now let's look at the second train. For the second train, I have only the x values, -4, 0, and 2. Now, if you've noticed, the y values are all the same. That doesn't matter. The only thing that matters is that the x coordinates are all different. So I have a -4, 0, 2. They are all different. So this one is a function. Now let's look at the caboose. Let's only look at their x values. So I see I have a -1, -1, and a 2. You see how these repeat? So therefore, this is not a function. Again, you want to pay attention to the x coordinates. If any element in the domain, your x values, is mapped to more than one element in the range, which is your y values, again, then it is not a function. So if you see this list of ordered pairs, 3, -5, -5, 6, 10, 3, and -4, 0. When we are putting them into these ovals called a mapping situation, the values must be listed in consecutive order. So from smallest to biggest. So let's take a look at my x values because those go in my domain. Remember, that's my x values. My range are my y values. So I'm going to put my x values in the domain circle. I have a -3, -5, 10, -4. Which one comes first? What's my smallest value? My -5 will go first, then the -4, as you can see here, then 3, then 10. For my range, I'm going to order them also in consecutive order from the smallest to the biggest. So I have a -5, -6, 3, and 0. So my smallest value is the -6, and the -5, then the 0, and the 3. We're going to map the coordinates to one another. So if you notice that 3, we're going to look at this coordinate here. 3 will map to the -5. I'm just drawing a line. The -5 maps to the -6. 10 maps to the 3. And -4 maps to the 0. That's how you do the mapping. Now, let's kind of start talking about the mapping and whether something is a function or not a function. So, determine if each mapping is a function or not a function. Remember, x values cannot repeat. So, here's our first example. You have 1, 2, 3 in the domain, -5, 3, and 9 in the range. Do you notice here how 1 maps to -5, 2 to 3, and 3 to 9? So those x values are not repeating, so therefore this is a function. Now let's look at this example here. I have a -1 and a 5 in my domain, and a -4, -1, 8 in my range. Right here, do you see how this 5 is getting mapped to two different y values, ranges? The fact that there are two arrows coming off of that 5 means that that 5 is repeating. So since my x value is repeating, this one is not a function. One last example here. Let's look at our last one. So I have -3 to 5, which is mapping to -2, 6. I want you to notice that 2, 5 maps to the 1, 6. Y values can repeat. X values cannot. Since there is one arrow from each one of those domain values, this is a function. Next, we're going to look at a table of values. So keep paying attention to the y coordinate. If an x value repeats, it is not a function. Here's our first example. We're looking at our x values. So x here is -1, 2, 6, and 8. So -1, -8, 2, 3, 6, 7, 8, and 10. Do we have any repeating? None of my x values repeat. They're all different numbers. So therefore, we'll say this is a function. Let's look at the next table of values. What do you think this is? Do I have any repeating x values? Looking at only my x values. -3, -1, 4, and 7. Nothing is repeating. So again, this is also a function. What about this last one? What do you notice here about your x values? The x values, I have two -2s. And since my x value repeated, this is not a function. Last, I want to look at the graphs. So when you're looking at a graph, there is a trick to determining if the relation is a function. This is called the vertical line test. You see over here, I have a purple vertical line. If a vertical line passes through more than one point, it is not a function. What I'm going to do is I'm simply going to pass this vertical line over this first graph. Do you see it hits one and only one point here? As I move along, it's only hitting one point. So since each and every point is the line's only hitting it one point, we would say that this is a function. Let's continue to the second graph. So as I go and approach point 1, it's only hitting 1 point. The line's only hitting 1 point here. Do you see on this one, I'm hitting 2 points in this section. So here I'm hitting 2 points at once. So therefore, this is not a function. Let's practice that skill just a little bit. So we're going to take the time to determine if this graph is a function or not. Take my vertical line, and if it crosses this graph or this line, linear graph here, if you notice there is no place that this is going to touch that graph in more than one spot. So that being said, we are going to say that this graph is a function. Let's pick a different graph here, see what we get. Now I have this graph. This is called the absolute value graph. You'll learn that more in algebra. So I'm going to pass along this vertical line. Is this vertical line going to touch this graph in more than one spot? I am not saying that it is passing through this and passing in more than one spot. It's only hitting the graph at one point throughout the entire duration. So again, I'm going to say this is a function. Let's look at one more graph here as an example. This is actually the graph of y squared equals x, and you'll learn that in Algebra 2. As I'm passing my vertical line, you see it only hits the graph in one spot right here. But as I start going, it's hitting in more than one spot. I'm hitting the graph here and here. So since it's hitting in more than one spot, we're going to say that this is not a function. So that's the conclusion of this video. If you have any further questions, please come in for tutorials and go ahead and complete your assignment.